Chapter 12, Section 7. Objective, learn to solve systems of linear equations by graphing. Essential question, how do I use a graph to identify a solution for a system of equations? A system of equations is a set of two or more equations that contain two or more variables. A solution of a system of equations is a set of values that are solutions of all of the equations. If the system has two variables, the solutions can be written as ordered pairs. We're going to start with the word problem to give it some context. A bus leaves the school traveling west at 50 miles per hour. After it travels 15 miles, a car follows the bus, traveling at 55 miles per hour. After how many hours will the car catch up with the bus? So imagine this is a bus that you're taking on a trip for a sporting event. And maybe your parents are coming following the bus, but they leave a little bit after the bus does. How long will it take for your parents to catch up to the bus? So we need some variables. Let t equal time in hours. Let d equal distance in miles. So the bus distance would be d equals 50 times t, because that's the speed they're traveling per hour, plus 15 because the bus is 15 miles ahead. The car distance would just be d equals 55 times t, because it's 55 miles per hour. So if we graph these two equations, starting at 0 and starting at 15, using the slope, we can see that those two equations cross on the graph at the point 3, 165. Therefore, after 3 hours and 165 miles, the car would catch the bus. If we want to check our answer, we take our point 3, 165 and plug it in for the time and the distance into one of the equations to see if it works. Now we try it in the second one, and both of them come out to be equal. A fishing boat leaves the harbor traveling east at 16 knots, which is nautical miles per hour. After it travels 40 nautical miles, a Coast Guard cutter follows the boat, traveling at 26 knots. After how many hours will the Coast Guard cutter catch up with the fishing boat? Let t equal time in hours. Let d equal distance in nautical miles. Fishing boat distance would be d equals 16t plus 40. And the Coast Guard cutter distance, d equals 26t. We graph both of these, and we find out that the point 4, 104 is the point of intersection. To check our answer, we plug the numbers in, and it works in the first equation, and it works in the second equation. Not all systems of linear equations have graphs that intersect in one point. There are three possibilities for the graph of a system of two linear equations, and each represents a different set of solutions. Intersecting lines with different slopes and intercepts will give you one solution. Parallel lines will have the same slope with different intercepts, meaning they start in different spots, but they move at the same slope. They would have no solution. That would be like two roads that are running parallel that will never cross each other. Lines that have the same slope and the same intercept would be the same line, which would be infinitely many solutions because they're identical. So let's see what we can do. The first thing we need to do is make sure these are in a form that we're able to graph. We know how to graph y equals 2x minus 7, but we need to get 3x plus y equals 3 into slope-intercept form. So we start with our first one's fine. Second one, subtract 3x from both sides. We get y equals 3 minus 3x, or negative 3x plus 3. Now we're ready to graph them. Remember, two of the parts we're looking for every time would be your y-intercept and your slope. So we have our y-intercept and our slope. The slope is always the number in front of x. So to graph 2x minus 7, we start down at negative 7, and we count up 2 over 1, up 2 over 1. For y equals 3 minus 3x, we start up at 3 and we go down 3 over 1, down 3 over 1. Now we look for where they intersect. It's a little bit hard to tell on here because it's a little bit skewed, but it should be intersecting at 2, negative 3. If we want to check that, we plug it into one of the points, make sure it works, plug it into the other equation, make sure it works. Let's try another one. Both of these need to be solved for y. So in the first equation, we need to subtract 2x from both sides. In the second equation, we need to add 9 to both sides. Looking at those equations side by side, they look to be identical. So when we graph them, start at positive 9 and go down 2 over 1, we have the exact same graph. So we would say there are infinitely many solutions to this equation system. We wanted to check, just set them equal, and 9 equals 9. That's it. Remember how to graph the slope and intercept? Starting at the y-intercept, using the slope to move up and over or down and over. And then you're checking to see where the points are that are intersecting from the two lines.